Hello, this is Memphis University. Today we're going to be practicing an AP Calculus free response question. The topic is AB multiple choice light questions. So these are the questions, the free response questions on the AB exam that are basically just a combination of multiple choice questions. It doesn't really fit under a big category like particle motion, area and volume, diffie-q, things like that. So just like for all those other ones, we've created 11 videos, one overview video, and then 10 difficulty videos where we go from difficulty 1 all the way up through difficulty 10. So this is our difficulty 9 video. It will be pretty challenging, but the reason why it's probably going to be challenging is because there's a lot of trigonometry, and a lot of students don't like trigonometry in terms of the unit circle and things like that. So actually, you might not think that this warrants a difficulty number 9 video, but we're still going to do it, and we're going to have fun, of course. So the first question is average rate of change. Usually when I talk about average rate of change, I like to review both average and average rate. So let's get started. So we have in our box here the difference between average value and average rate. So the average formula, meaning average value of f over an interval, average rate is also over an interval, is 1 over b minus a, the integral of f. So the average velocity, for example, is 1 over b minus a, the integral of velocity. The average rate of change of f, what I like to think about is there's two kind of rates of change. One is the rate of change over a time period, the average rate of change, that's this one right here. And then the second one is instantaneous rate of change, that is the derivative. So rates are always slopes, where for instantaneous rate of change, that will be your calculus slope, that will be your derivative. Average rate of change, because it's over an interval, you can have 2 points. That's going to be your algebra slope. So again, average value is going to be your 1 over b minus a, the integral formula, and then average rate of change is your average algebra slope. So in this case, all we're going to do is algebra slope. Keep in mind that the words of change don't really matter. The words value doesn't matter. It's either average or average rate. So in this case, we are going to do algebra slope on this function right here. E to the sine x times sine of x. We'll be using this quite often. So it's going to be f of pi over 2 minus f of 0 over pi minus 2 minus 0. So what we're going to get is f of pi over 2. That is going to be e to the pi over 2 sine of pi over 2. We're only plugging in pi over 2 in this function. Then the next point, the next y coordinate will be e to the 0 sine of 0. And finally, this will be all divided by pi over 2, of course. So e to the pi over 2, that's not a number nobody knows, so we're not going to simplify that at all. I don't know why I write this as an exponent. I kind of got confused with the exponential, but sine of pi over 2, remember this is the unit circle. So we're going to have sine of 0. That's going to be the point 1 comma 0. Pi over 2 is right here, of course. That's going to be 0 comma 1, and it's always the y coordinate. So if you need to, just draw a quick little unit circle to find these trig values, because sometimes that's helpful. So in this case, sine of pi over 2 is 1. Sine of 0 is 0. E to the 0 is 1, so we get minus 1 times 0 all over pi over 2. So let's simplify. Of course, this goes away, so you're going to be left with e pi over 2 divided by pi over 2. And some students have trouble with dividing by fractions, but remember that when you divide by the fraction, it's the same thing as multiplying by the reciprocal. So in the end, you are going to get e to the pi over 2 times 2 over pi. And this is our answer. So again, average rate of change, not too bad of a question, sort of a warm-up question as we do harder questions later on in this practice. But again, average rate of change is usually algebra slope. Excuse me, average value is usually 1 over b minus a, the integral. So in this case, just keep in mind that average rate of change is usually algebra slope, and it's one of the only questions where you don't take a derivative or an integral. So we have another question. The next question is, if g of x is defined as x cubed plus the integral of this function, what they want us to do is they want us to find g prime of pi over 2. Let's add to this. Let's try to find g double prime of pi over 2 as well. I'm not sure about you. You might not like to add questions to your test or anything like that. But here we're just having fun, so we might as well spice it up a little bit. So let me write out this function and replace the f of x with what it is. So it's going to be x cubed This is what g of x is. Plus 0 to 2x e to the x times sine of x, or really t's, which we use t's because the end integration variable is t's. So we have this right here. And then now we're going to take the, so this is a plus. I don't know why I wrote this. This is equal. So I couldn't do this really easy step. All I did was replace the f with here, but struggled a little bit. So now we're going to take the derivative. So the first part of the derivative is pretty easy. It's just 3x squared. And then here we have the fundamental theorem of calculus. I call it the second half of the fundamental theorem of calculus. Basically, what happens when you take a derivative of an integral. So this is the fundamental theorem of calculus. So remember, the rule is when you take the derivative of an integral, because they're sort of inverse processes, they basically go away. Like if you square something and square root something, you end up with the same thing. So if you take the integral of something and then take the derivative right afterwards, you're just going to get the same thing. So basically what we're going to do is we're going to plug this upper limit into this function right here. So we're going to go e to the 2x times sine of 2x. But what you want to be aware of is that when you do this process, you do have to do the chain rule because there's an inside function here. There's a 2x here. So what we're going to do is we're just going to multiply everything by 2. And this is again because of the chain rule. There's an inside function. We have the outer function is the integral itself. And then the inside function is this 2x. That's what we're plugging in. Notice we didn't multiply by 2 twice because there's a single inside function. We don't multiply by 2x for both of these. So this is the integral. This is the derivative, actually. The derivative of an integral. So you just want to keep in mind how to do this process. Again, it's one of the easier derivatives. All you do is you take your upper limit, plug it in, and then you multiply by 2. Keep in mind that this was the derivative, so you don't have to actually take another derivative for the g prime. So if we want to finish the question, all we're going to do is plug in pi over 2. So I don't think we're going to get something super interesting. Looks like we're going to get 3 times pi over 2 squared, because we're just replacing that x with pi over 2. Then looks like we're going to get, when you plug in pi over x into this 2x, you're going to get e to the pi. There's still this 2 in the front. I'm going to move it right here because I like to always take my constants out to the front. And then we have a sine of pi as well. So if we add to our unit circle here, pi is this point, -1, 0. So sine of pi is 0. So in this case, actually all of this went away right here because sine of pi is 0. So we're going to end up with 3 times, if you want to simplify, pi squared over 4. Because you square both sides, square both numerator and denominator when you have a quotient squared. So that's the first derivative. Again, the key by far is the fundamental theorem of calculus. All you do is you take this upper limit, plug it in when you want to take the derivative of something with an integral. Keep in mind that I think this is an easy question because it's a derivative question actually, not an integral question. But sometimes the College Board or the people who make the AP exam thinks it's a hard question. It's usually in the back half of the non-calculator multiple choice. So it's one of those questions that are towards the end of the multiple choice non-calculator that you can really dominate. But of course, we did add the second question, so we do need to take another derivative. But this derivative shouldn't be too bad. It should just be the power rule of this guy right here. Not the power rule, just power rule for this, product rule for this. So let's do that. Again, just going from this step to this step is taking a derivative. You don't want to be taking too many derivatives when you employ fundamental theorem of calculus part 2. So in this case, looks like this derivative is just going to be 6x. And then we're going to do the chain rule and the product rule at the same time. So let's make this my first function. And let's make this all my second function. Again, what you want to be careful about is that there's going to be a lot of times 2 in this case. Basically, we want to distribute this 2 for both sides of the product rule. So we got to be careful. And then there will be 2's coming out because there will be chain rules and stuff like that. So in this case, let's take the derivative of this guy first. So it will be 2e to the 2x. Again, this 2 is the chain rule of this guy right here. And then we'll keep all of this the same. And then we'll keep this the same now. And we'll take the derivative of this guy because we kept that one the same in the first half. So the derivative of sine of 2x times 2. Well, again, there's this 2 here, so I'm going to already write it down. Then the derivative of sine is cosine. Keep the inside the same. And then finally, there'll be another times 2 because of this chain rule right here. So a lot of times 2's. The first time 2 is because of the chain rule of the first one. And then there's times 2's for the chain rule of the second one for the product rule. Each part of the product rule had a times 2. And then finally, we wanted to distribute this 2 as we did both sides of the product rule. But of course, once you do that, the question becomes pretty easy. We're still plugging in pi over 2. So it looks like we're going to get 6 times pi over 2. We can simplify that later. Of course, e to the pi. We are again going to get sine of pi, which is 0. So that'll go away. Lovely stuff. We're going to combine these two 2's right here to be 4. E to the pi again, because we're plugging in pi over 2. And then we get cosine of 0. Not 0, cosine of pi. Because when we plug in pi over 2, we're going to get pi. 2 times pi over 2 is pi. So then we're going to simplify. It's going to be 3 pi. And then finally, it's going to be cosine of pi is -1 from this unit circle. So it's going to be -4 e pi. And you can't really simplify that, so that will be our answer. So hopefully that made sense. Let me again review this question because it is an important question. It does talk about the fundamental theorem of calculus. So all we did is we took the derivative. This guy was outside of the integral, so we just used a regular derivative for that, 3x squared. And then to take the derivative of an integral, all you do is you take your 2x, replace it all with the t's. But you do need to remember to multiply by the derivative of the thing you plugged in and not the thing you plugged into. So in this case, we multiplied by 2. And then we plugged in pi over 2, used some trig values to find that. And then finally, the second derivative wasn't too bad. We just had to be careful with product rule and chain rule and sort of distribution things and things like that. And again, at the very end, we plugged in pi over 2. So again, not too bad of a question. As I'm doing these questions right now, this might not be difficulty number 9 level. Perhaps if you watched our previous videos, you would have maybe thought that difficulties 7 and 8 were harder than this, but that's up for you to judge. But we appreciate you, of course, watching our videos. So this is probably a little bit harder question. Find the absolute max and minimum of f on the interval 0x to 2 pi. So what we're going to do is we're going to do our normal closed interval method to find absolute max or min. So what we need to do is we need to locate the function. And we're going to take the derivative and so on. So in this case, the function is still our thing from the very beginning. It's going to be e to the x times sine of x. That's f of x, so we can write equal here. So I like to write out this stat because when I'm plugging in to the function later on, it's just easier when the function is right there in front of me. So number 2 is critical point steps. This is taking the derivative and setting it equal to 0. So let's do that. So it's going to be e to the x times cosine of x. Again, I'm employing the chain rule, product rule, not the chain rule. No need for the chain rule here because the inside functions are both x's. And then, so we kept the same, took a derivative. So we're going to take a derivative, but that's just e to the x, of course. And we're going to write that. And then we're going to set this to be equal to 0. So what we need to do is we need to find this 0. Unfortunately, we do not have a calculator here, so we do have to solve these zeros. And this is where it becomes a little bit tricky because we do have to deal with trig. But before we do that, just let me remind you that this second step is really critical points and not just the derivative. Sometimes they'll give you a point by just setting this derivative to be equal to 0, even if you find the wrong 0. So just be wary of that. It's nice to get in the habit of not just writing the derivative in the step. Just write the derivative equals 0 and you might get an easy point. But what we're going to do is we're going to first divide by e to the x to make this easier. And why can I divide by e to the x? Well, e to the x is always positive, so it's never 0, so we can divide by e to the x. So what we're going to get is cosine of x plus sine of x is equal to 0. And then we have to solve this, so it's going to be sine of x is equal to negative cosine of x. So what we need to look for is, usually by this step, I can just draw a sine chart, or maybe I can just factor or something like that, where I can easily see where the zeros are. But in this case, we have trigonometry. So again, we're going to go back to that unit circle. So what we have to think about is which angles on the unit circle has same sine values, or actually the sine value is the negative, the cosine value. So if you want to think about angles like pi over 6, pi over 3, pi over 4, or if you want to say 30, 60, 45 degrees in terms of degrees instead of radians, remember that sines and cosines are the same, or the negatives, when you have pi over 4s and 3 pi over 4s and 5 pi over 4s and stuff like that. So this is pi over 4. Keep in mind that we're on the interval 0 to 2 pi. So this is 2 pi, not 2 pi over 4, this is 3 pi over 4. These are all the 45-degree angles. This is 5 pi over 4. And this is 7 pi over 4. If you want, you can write this as root 2 over 2. We'll label a few of these. Let's label this one and this one. So this one is going to be root 2 over 2, but negative on the second corner. So all of these have the same sort of points. So again, this question isn't hard because of the calculus. It's hard because of the trig. And trig is kind of annoying sometimes. So we have this right here. I'm not going to label this point because we're not going to need it. But basically, we're looking where the sine of x is equal to the negative cosine x. Again, on the unit circle, sine is equal to the y value. Cosine is equal to the x value. So notice in this one, the sine will be equal to the cosine, so we don't want that. We actually want these 2 points right here. Because notice for 3 pi over 4 and 7 pi over 4, the x-coordinate is negative the y-coordinate. This is a negative right here. So these are the two numbers we want. X is equal to 3 pi over 4, and x is equal to 7 pi over 4. For 5 pi over 4, both the cosine and the sine will be negative, so we do not want that. That will give us sine of x is equal to cosine x. So now we're ready to construct the table. It shouldn't be too bad. Remember that when you do this method, it's always the locate step and not the given. Sometimes the given matches, like in this question, but sometimes the given is another function. So in the closed interval method, what you do is you plug in your endpoints. And then you also plug in any critical points that fit within those endpoints. So it's going to be 3 pi over 4 and then 7 pi over 4. Great. And then finally, what we're going to do is we're going to take these 4 numbers and plug it into our function slowly. Again, using sine values. So the easy ones actually are 0 and 2 pi, because when you plug in 0 into either of these, sine of 0 is 0. And 2 pi is the same angle as 0, so sine of 2 pi is also 0. So that's not too bad. Then, when you plug in e to the 3 pi over 4 and e to the 7 pi over 4 into this function, so it's going to be e to the 3 pi over 4. Can't really simplify that at all. And then sine of 3 pi over 4 is square root of 2 over 2. So that's going to be square root of 2 over 2. Then when you plug in 7 pi over 4, it'll be the same thing, sine of 7 pi over 4, but it's the negative because it's the y-coordinate. So it's going to be e to the 7 pi over 4 times negative root 2 over 2. How lovely. And we are done. And actually, even if these numbers are very complicated, my favorite number in the world is not e to the 3 pi over 4 times root 2 over 2. It will still be easy to tell which one is the max or the min, because this is a positive number. Again, e to any number is positive. So this will be a positive number, and then this one will be a negative number. So this has to be the max. This has to be the min. So let's write that. They asked for the value, find the absolute max or min value on f, so we're going to have to list that. But I like to always list out the value and the where it occurs. So let's make a nice little box here. So the abs max, you should probably write out the word absolute maximum, but I'm kind of lazy right now, is this number right here, the positive number, e to the 3 pi over 4 times root 2 over 2. And we can write x is equal to 3 pi over 4. And finally, the abs min is e to the 7 pi over 4 times root 2 over 2 at x is 7 pi over 4, or negative root 2 over 2, let's be careful. equals 7 pi over 4. And if they asked me to justify my answer, I wouldn't have to add anything else because the table and the answer and then all of this work is the justification. Keep in mind, if this was a relative min or max, sign charts don't give you points, so you do need to justify with a rule like f has a rel max or relative max when f prime goes from positive to negative. But again, this question wasn't too bad. It was still the closed interval method. We located the function, we took the derivative, found the zeros, and then plugged in critical points that fit within those zeros. Within the endpoints into this table where each one we plugged into the f value. Just keep in mind the hard part was just finding what the values actually were. What we needed to think about angles where the sine of that angle is equal to the negative cosine of that angle. We found that they were going to be pi over 4s, and in particular, they were going to be 3 pi over 4 and 7 pi over 4. Keep in mind, though, that there's actually an infinite number of angles that satisfy this equation. So, for example, negative pi over 4 is the same thing as 7 pi over 4 on the unit circle, so that would have also been a zero, a critical point. But we are only dealing with critical points that fit within our interval, so that's why we did not have to consider negative pi over 4. So again, this question wasn't too bad. Perhaps, again, this difficulty number 9 video isn't what its name, it doesn't live up to its name, but again, trigonometry is pretty hard. A lot of my students struggle with it. Perhaps it's because I teach them trigonometry and I don't teach them too well, but if you're really good with trigonometry and knowing the unit circle and things like that, then this question hopefully wasn't too bad. So finally, we have this strange L'Hopital's question, L'Hopital's rule. They've asked this question in the past. Remember that L'Hopital's rule is the most recently added topic to the AB exam as of the recording of this video, 2020. So oftentimes on the AP exam, you want to be wary, certainly, that if ever you're taking a limit, then that limit could potentially be L'Hopital's rule. And in this case, what they're going to do is they're going to use the limit. So we have actually the limit. We're not going to try to find it. But what we're going to try to do is use the limit to find g of 0 and g prime of 0. So this is an interesting question. They've never asked the L'Hopital's rule sort of in this way until very recently. So it is a nice question to talk about. So we have this function here, h. It's a new function. F of x is still the function from before, so we can write that down on the side. So remember, f of x is equal to e to the x times sine of x. So we have this new function, g of x, and we want to just find g of 0 and g prime of 0. And what we know is that this function, you can take this limit using L'Hopital's rule. It's valid to use L'Hopital's rule. So what are the requirements for L'Hopital's rule? Well, the main requirements are that when you take the limit of this function, over 4 minus g of x, that means that the numerator of both, the limit as x goes to 0 of both the numerator and the denominator has to be 0. So we know that the limit as x goes to 0 of x minus f of x is equal to 0. We actually know that already because when you plug in 0 here, you'll get sine of 0 is 0. So 0 minus 0 is 0. That's fine. We don't really care about f of x because we already have that presented. What's more important is that the limit of the bottom is also equal to 0. So what we're going to do is we are going to plug in 0 here. So we're going to get 4 minus g of x is equal, 4 minus g of 0 is equal to 0. So it must be that g of 0 is equal to 4. Great. So that's one of the numbers we were trying to find. So again, in this question, we use the fact that the limit of the bottom equaling 0 has to give us what g of 0 is. And so that was a nice thing. The requirements of L'Hopital's rule, we haven't even actually done L'Hopital's rule, but just the requirements gave us this guy right here. So now what we're going to do is we are going to now apply L'Hopital's rule. So the usual question is apply L'Hopital's rule to this function right here. And what we would do is we would write limit of the top equals 0, limit of the numerator equals 0, and then limit of the denominator equals 0. And then we would write by L'Hopital's rule, or L'Hospital's, if you want to pronounce it funny. You write your original limit, so that's this guy right here, we can replace f of x with this function. And then how do you apply L'Hopital's rule, or how do you lope that tall? Well, what you do is you take the derivative of the top and then the derivative of the bottom. Keep in mind that the derivative of the top right here does use the product rule because we did that earlier. And just like we were doing in the first page when we had this 2x business, we have to distribute this 2. Same thing here. We're going to have to distribute this negative. So let's take the derivative of the top. Let's build our confidence. We can do this, team. So it's going to be 1 minus, so the derivative of x is 1. Again, I'm treating this function as minus e to the x times sine of x when I do the product rule. So it's going to be minus e to the x times sine of x. I really took a derivative of this. And then there's another minus because I'm going to keep this function the same, times cosine of x. Again, what I'm trying to really focus on, and what I always try to encourage my students to do, is to be careful with these negatives, especially when you're doing product rule. Basically, the negative has to distribute to both halves of the product rule. The second half is pretty easy. The bottom derivative, it's just going to be g prime of x with a negative because the derivative of 4 is 0. Probably there would be more givens in this function, like it would say something like g is differentiable, so that g is continuous, something like that. That would have been a better worded question. So let's add that as the given. G is differentiable. Because if g is differentiable, that makes this question more rigorous in terms of the answers. Because remember, differentiability implies continuity. So the limit of x goes to 0 of g of x is equal to g of 0. So when we take this limit, we can just replace limit of g of x with g of 0. This is the definition of continuity. Keep in mind, the last or 2 videos ago, we did a piecewise function, which often asks these continuous questions. To show something is continuous, you need to show the limit equals the function value. So because we have continuous, because we have differentiable, what we're going to do is we are now going to we're going to plug in 0 like normal. So let's plug in 0. So it's going to be limit as x goes to 0. Sine of 0 is still 0. That's great. Oh, this is not the best question in the world. Unfortunately, I'm going to change the question just to make it look nicer. Sorry about that. This is not how you do math, but whatever. I don't want a bad answer, so I'm going to change these to 8s. It doesn't affect this function right here, and then when you take the derivative, it just becomes an 8. So again, my apologies, but we want this question to matter. So when you plug in 0 here, you will get 1. So that's why I didn't want it to be just 1 minus 1 and then you get 0 on the top. So I'm going to, now it's 8. So we're going to have 8 minus 1 is 7. And then we're going to set that this is negative g prime of x. And we're going to plug in 0 now. So this limit is going to be 7. This is still an x then. Really struggling in the end, but forgive me for that mistake. Basically, we wanted a better written function and I didn't actually try it out. But in this case, it sort of makes sense now. So usually what you would do at this step is you would plug in 0 to find this 0, to find this limit in the end. But keep in mind that they actually gave us the limit. So what we're going to do is we're going to set this to be equal to 1/4. And then we're going to solve for g prime of x. And if you do, you cross multiply the g prime of x, cross multiply this 4. And then you'll find that g prime of 0 is equal to negative 28. So we had this weird L'Hopital's question. But instead of finding the limit, we were using the limit to find derivative values and the function value. How we found this g of 0 was because this g was differentiable, the limit is equal to the function value. So because this limit can be evaluated with L'Hopital's rule, we know that the denominator has to be equal to 0. So we got g of 0 is equal to 4. Then we actually took the limit. We did change the question in the middle. You're not allowed to do that on tests, but here we're just having practice. So we had 8x minus e to the x times sine of x. We changed this to an 8 because it made the question better. We plugged in 0, and instead of setting something, plugging in something to find the limit, we set it equal to the limit that was given, 1/4. So we were able to find g prime of x. G prime of 0 was negative 28 after we solved. So hopefully that made sense. Let's review exactly what we did. Keep in mind that for all of these questions, we have videos on all these topics. So we have videos on average rate of change, if you want to focus on that, fundamental theorem of calculus part 2, and the product rule, of course, the chain rule, of course, absolute max or min, the closed interval method, and also L'Hopital's rule. So be sure to check those out if you want to sort of more practice on particular examples. But let's go over what we did today. Average rate of change is algebra slope. Average value is 1 over b minus a, the integral. In this case, we were just doing algebra slope. No need for derivatives in this case. All we did was we found y2 minus y1 over x2 minus x1 using the unit circle. Then we had a derivative of an integral. Not too bad. We just have to remember to plug it in, plug in the upper limit into the function, and then multiply by the derivative of that upper limit because that's the inside function. And then when you're doing product rule, just be careful with parentheses and distributing constants and things like that, and chain rule, of course. Then we did an absolute max or min question, which was our 3 normal steps. Locate the function, critical points, and drawing the table. In this case, the locate was the given, so we just took the derivative. We did have to find these angle values, and they were pretty difficult, but we used the unit circle again. Thought about whose sine values are equal to the negative cosine value. Once we did that, we fit those critical points and those critical points that fit within the interval into a table, plugged in these values into our function like normal, and solved. Finally, we had this weird L'Hopital's question. We did change the question in the middle, which was a bad thing to do, but hopefully that made sense of why we did it. Sometimes we make mistakes. Your teachers make mistakes. You should never feel bad to make mistakes. I make more mistakes than probably you do, but the point of mistakes is to improve and things like that. So by looking through the question, I realized that the question was a bad question, so we changed it. But in this case, it was finding L'Hopital's rule and using L'Hopital's rule to find these two values right here. And what we did is we set the limit of the bottom to be equal to 0 because that's one of the conditions for L'Hopital's rule. And we were able to solve because g of x was continuous. And then we also took the derivative. Keep in mind that we didn't confuse derivatives, sort of L'Hopital's rule with quotient rule. This is just taking the derivative of the top and the bottom. Quotient rule is to take the derivative of quotients. L'Hopital happens to use derivatives in it, if that makes sense. Then what we did is we just plugged in 0 here after taking the derivative. When this number is an 8, it's a lot better. So we got negative 7, and then we just solve for g prime. So hopefully, again, this video was useful, even if I did make a mistake in letter D there before I wrote the questions. Keep in mind that we have one video to go, so I would encourage you to watch that. That video, difficulty number 10, consists of 4 random multiple choice questions that I think people would have trouble with. So check that out if you want a little bit of a challenge. Thanks again for watching and supporting our channel. We definitely appreciate that so very much. And I hope to see you soon in that difficulty number 10 video. Thanks again for watching.